28 through 38 on this segment. A triangle has vertices at 1, 3, 2, -3, and -1, -1. What is the approximate perimeter of the triangle? So when they ask you for perimeter, you know you're going to have to find lengths. And if you have to find lengths, what formula would you use? So you use distance. And again, I graph it in my mind and I put it on my paper. I'm thinking I'll go over 1 and up 3, so I'll put a point here. That's my 1, 3. And then you think about it, you'll go over 2 and down 3, so you're right here. And you put your connect, and then you go left 1 and down 1, so you're right around here. That just gives you a visual. And now you find the length of each of these lines by using your distance formula, and you add them up, and you have your perimeter. And so right here, let's go ahead and find the length of this one. So the distance is equal to, reminder, is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So you put the plus between them and you subtract within your parentheses. And if you do that, you have -3 minus 3. Well, let's do our x's first, since I set up x's first. 2 minus 1 squared plus -3 minus 3 squared. That way it'll follow directly from here. Although it really doesn't matter if you flip those, as long as you have your signs and everything in the right place. 2 minus 1 squared is 1 squared. -3 minus 3 is -6, but don't forget you have to put -6 in parentheses. So when you have -6 squared, that's going to go to positive 36. So you have the square root of 1 plus 36. So right here you can leave that. You can leave that as the square root of 37. Okay? You do the same thing right here. Distance is equal to, you subtract your x's, 2 minus -1 squared, plus, you subtract your y's. I use the 2 first, so I'm using -3 first. -3 minus -1 squared. Well, that's equal to 3 squared. And -3 minus 1 becomes -2 squared. And that's 9 plus 4. That's the square root of 13. So right here you have the square root of 13 for this length. And then you have to do your very last piece, and then you're going to add them all up. So let's go where would we like to do this. Let's do it over here. So the distance is equal to, for your x's you have -1 minus 1 squared plus -1 minus 3 squared, which is equal to -1 minus 1 is -2, but -2 squared is 4, and -1 minus 3 is -4, but -4 squared is 16, and 16 plus 4 is 20. So now we have the square root of 20. And what you would do on your calculator is you can go ahead and put these in. So the perimeter is the distance around. If I ask you to run the perimeter of Hillside, you would run around Hillside. So you do square root 20 plus square root 37 plus square root 13. So what I'll do is I'll go ahead and pull up the calculator so you can see how to put that in the calculator, and then we'll check to see what our answer is. So let me turn this off. If you need to pause to make sure you have it all correctly written, you can pause it and then turn it, and then we'll look at what we have to look at next. So now I'm going to pull up the calculator so you can see how you would put the radicals within the calculator. Okay, let's go to second. Oh, well, let's just clear it. All right. I'll clear the history of what we just previously did. And I'm going to put in what we have. We had the square root of 20, so you hit second x squared to get your radical symbol, and you put in your 20 and close your parentheses. Then you will put your plus sign. We also had the square root of 37, so we're going to hit second x squared, put in your 37, close your parentheses, and we had the square root of 13. So put in second, x squared, 13, close your parentheses, and hit enter. And you get approximately 14.16. And then if you look at your multiple choice answers, what answer would that have to be? That would have to be letter B, which is 14. So the answer to number 27 is 14. And you can see that right there, that B is 14. Okay, let's go to number, did I say 28? Okay, the answer to number 28 is 14. Let's go to number 29. Number 29, the table below shows the area of several states. Delaware has an area of 2,000 square miles. So which is true of Delaware if Delaware is included in the data set? Will the average go up? Because remember, the mean, which can also be written like this, is the average. So with the mean increase, if you look at these numbers, they're in thousands. So 6 really means 6,000. 59 means 59,000. So think about where 2,000 is in this group. The range decreases. Remember, the range is the maximum number, which is the highest, minus the minimum, which is the lowest. Let's see here. The interquartile range decreases. Remember, if you have a box and whisker plot, your interquartile range is going to be this minus Q3 minus Q1, okay? So that's your interquartile range. So they're saying the interquartile range decreases, or the standard deviation increases. And the answer is D. The standard deviation increases, because I'll write this down for you. The standard because the data is going to be more spread out. The standard deviation is bigger when the data is more spread out. Okay, so 2,000 is going to spread the data out a little bit more because 2,000 is not very close to a lot of these numbers. So that's going to make your standard deviation larger. Okay. Let's move on to number 30. For number 30, a college surveyed 3,500 or 3,500 of its students to determine if the students preferred music, movies, or sports. The results of the survey are shown in the relative frequency table. Keyword here, relative frequency. So we think percents. So what we have to think about is that relative frequency means percent. So instead of 0.06, we're going to think 6%. Because for percent, remember you multiply by 100. Think about what you'd like to get on any of your tests, a 100. So you want 100%. So you multiply by 100 to transfer these to percents. We want to know how many more seniors than juniors were included in the survey. So we need to look at only the juniors and the seniors, okay? We know that the college surveyed 3,500 students. So what you can do is add up all your junior percentages. So for juniors, we have 10%, because we changed that decimal to a percent, plus 6%, plus 8%. So we have 24% juniors. And then for seniors, we have 8% plus 9% plus 10%. So that's 27%. So if you want to know the numbers, you would take 24% of 3,500 for your juniors and 27% of 3,500 for your seniors. Remember, of means multiply, so that's 0.24 times 3,500, because when you multiply, you want to change that back to a decimal. And 0.27 times 3,500. And when I did that, what I ended up with is, 840 juniors, and I ended up with 945 seniors. But I have a comparison. It said how many more So I'm gonna have to use subtraction. So we have 945 minus 840. And you see your answer is B, because there are 105 more seniors than juniors. Let's move on to number 31. Okay, for number 31, we have a book club. A book club has 200 members, so that's good. We know how many members we have. Each member was asked whether he or she prefers fiction or nonfiction books. The results are shown in the relative frequency, so we have more relative frequency table, more relative frequency. So it's shown into the relative frequency table below. So what is true? So I looked over these statements, 6 more 31 to 40-year-olds than 21 through 30-year-olds prefer fiction. So I checked that out to see if that were the case. Then I said, that looks a bit complicated. Let's move to the others. 38 members are 31 to 40 and prefer fiction. So I looked at 31 to 40, I looked at fiction, and so I'm looking here at 0.38. So I said, let me see if that comes out to what it needs to come out to. So I did 0.38 times 200. That's 38% of your 200 members. And I got 76 members. So I can eliminate this. This is not right. So then it says 43 members are 21 to 30. So I go for 21 to 30, and they tell me that 43 members are in that range. So I go to the total members for 21 to 30-year-olds because they didn't specify fiction or nonfiction. They were just talking about this age and the total. So now I'm going to take 0.43 times 200. And when I do that, I end up with 86 members. So I can tell this is also not correct. Then I look at my 140 members prefer fiction. I go to my fiction column and look at my total. So I'm going to look at 70% of 200. So it's 0.70 times 200. And when I multiply that, I get 140 members. So I know that I am correct. So it's letter D. So we don't even really need to touch A. So if you find one that looks a little complicated, keep going, see if you can find the answer, and you don't even have to touch that one. So the answer to number 31 is D. Let's move on to number 32. Okay, for number 32, the table below shows the distance a car has traveled. What's the meaning of the slope of the linear model for the data? So what you have to do is you can actually use your calculator, put this in, find your slope, and once you find your slope, you'll know what it means. So, or actually what I did, I just used the slope formula and figured it out myself. So you can choose two ordered pairs. I chose these last two. So I did y minus y, which is 100 minus 80, divided by x minus x, which is 125 minus 100. So that's 20 over 125 minus 100, which is 25. And then I divided, I reduced it. I know that 5 goes into 24 times, and 5 goes into 25 5 times. So my slope is going to be 4 over 5. So that means, and when I do this, since your y is in miles, this is going to be 4 miles because your y is your numerator, your y is your rise, and your denominator is your minute, minutes. I don't want to say it like that, but. So you have 4 miles every 5 minutes. That's got to be letter C. The car travels 4 miles every 5 minutes. So if you want to figure out the units, look at the units here. I know I put that in my numerator, so my miles have to be first right here. And I know I put this part in my denominator, so my minutes will be in my denominator. Okay, let's move on to number 33. 33 is pretty nice. It's a formula. So all you have to do is understand the pieces of the formula. And if you understand the pieces of the formula, you can just substitute. The area of a trapezoid is found using the formula. Area is equal to 1/2 the height times base 1 plus base 2. So you have base 1 and base 2, and then you have your height, where A is the area, H is the height, and B1 and B2 are the lengths of the bases. So now it's just a straight plug-in. Area is equal to 1/2 the height times base 1 plus base 2. Well, area is equal to 1/2 of 4 times x minus 3 times x plus 7. Excuse me, plus x plus 7. You add. I want to use polynomials and do some multiplication, but you don't do that. You go ahead and plug that in for that, you plug that in for that. And what's half of 4? We know half of 4 is 2, so we just go ahead and figure that out. And then we're going to add our like terms. 1x plus 1x is 2x. Negative 3 plus 7 is positive 4. Okay, so let me make this a little more clear for you. The x plus x is 2, and negative 3 plus 7 is 4. We use our distributive property. So the area is 4x plus 8. And that is letter B. That's how you do number 33. Let's move on to number 34. 34 can be a little complicated, but it's not too bad. The main thing in 34 is to remember your boundaries. So if you go to number 34, a company produces packs of pencils and pens. Now when I see this, I start writing equations. It says the company, I'll write inequalities in this case. The company produces at least 100 packs of pens each day. So that's my lowest number. And we're talking about pens, but no more than 240. So now I know that the pens will be less than or equal to x, which is less than or equal to 240. X represents your pens. The company produces at least 70 packs of pencils, so we're talking about pencils now, each day, but no more than. If it's no more than, it could be that amount, so that's how come you put the less than or equal to. So no more than 170. So that's how you would set up your boundaries. A total of less than 300 packs of pens. That's important. Less than is very important. And pencils are produced each day. So the pens and pencils put together, it's going to be less than 300 packs. Each pack of pens makes a profit of $1.25. Each pack of pencils makes a profit of 75 cents. So now what would you do to this problem? When you have your boundaries, we know that the pencils cost less, so we're going to get the least number of pencils that we can get. That's 70. So now we're going to multiply 70 times 0.75 to see how much that costs. Plus, let's see, if we have 70 pencils and we have to have less than 300 with the pens, we have to figure out how many pens we can have. So we're going to do 300 minus our 70 pencils. That's going to be 0. So it looks like we could have 230, but that's going to take us right up to 300, and we have to have less than 300. So we're going to use 229. So we're going to have 229 pens, but then if you look at the cost of pens, pens cost, where is it? $1.25. Okay, so you're going to do your pencils plus your pens, and that's going to let you know your answer as to what you need. Let me see what I got when I multiply. So for 70 times 75 cents, I got $52.50. And then when I multiply 229 times $1.25, I got $286.25. And when I found the sum of those, when I added them up, I got $338.75. So that's your A. Be careful, make sure that you don't go below 70. You cannot go below what they give you as your minimum, okay? So that's how you get that answer. Let's move on to number 35. $35 is a little complicated, but don't worry because I'm going to show you how to do it and you'll be okay. After we do number 35, you'll be fine. 35. John mixed cashews and almonds. John bought 4 pounds of almonds. So we knew their almonds about 4 pounds for a total of $22. The cost per pound for cashews is 6% more than the cost per pound of almonds. John bought enough cashews that when he mixed them with the almonds, the mixture's value was $6.50 per pound. and that's when he mixed them. So now we have to figure some things out. First, let's figure out how much is it a cost per pound for the almonds. So for the almonds, we want to know the cost per pound. So let's put the cost in the numerator and the pounds that we have in our denominator. So it's $5.50. When you divide, you get $5.50 per pound for your almonds. So now what we do know, it's not so bad, we know that 5.50, so we can put 5.5x for our almonds that we mix with our cashews, where our cashews are 5.5 times x plus 0.6. And think about where that 0.60 is coming from, because it's 60% more. Good. So then we have to set this all equal to $6.50. And so we're going to distribute, always distribute before you combine these first two. A lot of times people try to combine them before they distribute them. Let's go ahead and sometimes that doesn't work out. Here you might get lucky because there's a 1 there, but lots of times that will not work out. And then when you do 5.5 times 60 cents, you're going to get 3.3. It's equal to 6.50. And now when you add your like terms, 5.5 plus 5.5 is 11. Now we're getting into a two-step equation, so we subtract 3.3 because we're solving for x. Line up your decimals. You can use the calculator on the calculator active section to make it faster. So you get 3.20, divide both sides by 11, and then you're going to get 0.29, which is approximately 30%. So it's approximately 30%, okay? So you have to round a little in that problem. Let's move on to number 36. For number 36, Lucy and Barbara began saving money the same week. The table below shows the models for the amount of money Lucy and Barbara had saved after X weeks. So you have your models. After how many weeks will Lucy and Barbara have the same amount of money saved? That's nice because that's substitution. If f of x is equal to this and g of x is equal to this, and they want to know when it's the same means equal. So you will set one equation equal to the other equation, and you'll solve for x. Go ahead and do your solving. Okay, so let's just work our way down. I'm not going to go through the solving steps. You should be pretty good at this by now. I'm just going to write it. And you can always view it if you need to look over it and make sure you understand it. So you get 8, so your answer is 8 weeks. Okay, so that is number 36. Once you get your setup, you're good to go. It's just setting it up. Let's move on to number 37. For number 37, Colin noticed that various combinations of nickels and dimes could add up to 65 cents. Let x equal your nickels and let y equal your dimes. What's the domain where y is a function of x and the total value is 65 cents? So I thought about what would be the easiest way for me to do this problem. Well, I said I'm going to make a table. So x would be your nickels and y is your dimes, because that's what they want us to do. So if we have 1 nickel, that's 5 cents. So we have to say, what can I add to 5 cents so I can get 65 cents? And it's 60. So it takes 6 dimes to make 65 cents if you have 1 nickel. Then we go to 2 nickels and we get 10, and we realize we can't add 10 to any dimes to get 65 cents, so we drop that. So we go to 3. So we can already eliminate this problem and this problem because we can't use the domain. The domain means what can my x's be, okay? The domain means what can my x's be. The range is what can my y's be, okay? Your y's are dependent on your x's. So what we put in for our nickels determines how much we have left for our dimes. Well, 3 nickels would equal 15 cents. So you determine how many dimes do I need to get to 65? Well, okay, I need 50 cents, because 50 plus 15 is 65. Well, it takes 5 dimes to make 50 cents. Then you go to 4, well, that's going to give you 20 cents. You can't add 20 to any dimes to get 65, so 4 is not a good one. So we move on to 5. If you have 5 nickels, you have 25 cents. If you have 25 cents, it takes 40 cents more to get to 65. So that means you need 4 dimes. 6 is not going to work either because that's going to give you an even number that ends in a 0, which means you're not going to get a number that ends in a 5 when you add it to 10. So you move on to 7. 7 nickels would be 35 cents, so you would need 30 cents more to get to your 65. So you need 3 dimes. And you continue with that logic. So you go with 9, and you're going to have 45 plus 20 cents. And so you're going to need 2 dimes. And then you go to 11. Well, that's going to be 55 cents plus a dime because it's 10 cents. And then you could also have 13 nickels and no dimes at all. Combination of nickels and dimes, that's interesting. Okay, so you have 65 cents. So this would be your 1, 3, 5, 7, 9, 11, and 13 would be your domain. So your answer to this problem is D. Okay, that's how you would do number 37. That's really the easiest way to think it through and see it also. 38, let me move on to number 38. The value of an antique car is modeled by the function v of x is equal to 107,000 times 1.009 to the 2/3 x, where x is the number of years since 2005. By what approximate percent rate is the value of the car increasing per year? So I made a little table. In my table, I said, okay, I put time here, and then I put the car price here. At time 0, it's 107,000. Because if you put a 0 for x, that means that's a 0 power, and anything to 0 power is 1. And 1 times 107,000 is 107,000. So that's your initial value. Then you start kind of plugging in. If you plug in a 1 here, then this is what you're going to get, 107,641.0408. And if you plug in a 2, you're going to get 108,285.922. And then you start looking at the difference between here and here. So what I did was I changed these to decimals, because even though they look like decimals, they're not, because it says percent. So you have to go 2 places to the left. So it's 0.0004 times your initial value, which is 107,000. I get 42.8. Okay, so it's telling me to get from here to here, I just add 42.8, which is not true, because I went all the way from 107,000 to 107,600. So now you're going to do the same thing with this. You're going to change this to a decimal. So you divide by 100, which moves you 2 places left. 0.0014 times 107,11000 is, see what I got there, 199.8. Let me double check that. It's very hard to see on my paper. 0.0014 times is 149.80. Yeah, something like that. Well, I know to get from 107,000 to 600 is more than 149. Okay, so I know that's not right. Let me try the next problem. Go back to 0.0060 times 107,000. And what I got here was 642. Well, that looks wonderful, because to get from here to here is approximately 642. So I know C is my correct answer. So the answer to number 38 is C. Okay, on the next presentation, we're going to do 39 through 50.